Hey, hello, and welcome to the show. It is me, JP, and it's time for John Park's workshop. Here we are in the workshop, just like the sign there says, right inside of the revolving Lars's. And I am happy to have you here today and excited to get to it and do some fun stuff in the workshop. First thing I'm going to do is actually fix, I think I put a typo in the coupon code for today. Whoops. So let me go fix this right now. Because today's coupon code is lemons, not lemon. Let me fix that real quick. Woo! All right. That's what it really is right there. Will this one be fixed too? No. Let me fix it here too. Oh, I made two of them and I made them both wrong. If you have a problem with that, try the singular version, but I'm pretty sure that's right. I'm pretty sure today's coupon code is lemons. What's all this talk about a coupon code anyway? Well, if you want to get some stuff in the Adafruit store and you want to get 10% off on your way out, then go ahead and head on over to Adafruit.com, head to the products section, load your cart up with good stuff. And by stuff, I mean things, not gift certificates and subscriptions and software. Those won't work, but actual things. 10% off through till midnight East Coast time tonight, I think is what it's set for. And I am 90% sure it's lemons and not lemon. And that is related to nothing other than the fact that we have a Meyer lemon tree that has a whole lot of lemons on it that I need to pick after the show, and I didn't want to forget. So that's a note to me. That's a note to myself. That's my to-do list. My today's to-do list is the coupon code. It won't always be that way, but today it is. So what else is new? What else is happening? We don't have any rain today, which is nice. We've had a couple of dry days. I think the rain is supposed to start up again soon, though. So I only have one leak here in the workshop. It's over there, and right now it's dry. But I got to put a bucket under there and then figure out where that leak is coming from. That's a lot of fun. What else? Oh, did you know we have a job board? It's right here at jobs.adafruit.com. If you head on over to jobs.adafruit.com, you can look for work. You can go ahead and post a position if you're looking to hire someone. And you can see here we have a position for someone at Adafruit. You don't need to see that on here, but right now we have an Adafruit position open for an employee resources assistant in benefits and payroll. It's full-time, and I think as Phil and Moore were saying, it might be okay for it to be partly remote or remote, but it does have to be in New York State. I believe that's what they said, but double check that. You can click on that link and find out more. It might even say, let me look and see, does it say anything about, partial remote work will be considered once training period has been completed. But it is an on-site position. So partial remote is the idea there. And that's at jobs.adafruit.com. So if you're looking for some work, head on over there and check it out. Well, let's see. What else is happening? The chat, if you're wondering who I'm talking to, what I keep looking at over here, these are the chats. We have YouTube chat, so hello to anyone who stops by there. Dave Odessa, I see, is over there right now, and appreciate you stopping by. The other main chat is, oh gosh, Todd is posting Photoshoppery, or he uses Preview, actually. But it's not always that silly. Yeah, actually, it kind of mostly is. But here's the chat, and it's at adafruit.it/Discord. That'll get you the instant link. It's the easiest way to get on over to Discord. Find our server there, and then you can look for the live broadcast chat channel. But we also have things like this right here is the general chat channel. We have project help channels. We have help with CircuitPython channels, all kinds of different things to go and check out there. But during the show, you can head over to this one. I'm going to hide that now. Thanks, Todd. And ask questions. You can ask me questions. You can answer other people's questions in there. You can do things entirely unrelated to questions. Just chat. That's the chat over on Discord. What else? I've got a bunch of new guides over in Learn. So if you head on over to learn.adafruit.com, this is it right here. And if you scroll down, you can always find out what new guides there are just by looking for this New Guides section and click on View All. And that'll take you through all the latest guides. I think these are within the last 90 days is this list, so you can check out what's been going on for a few months here. I can see lots of new boards as well as projects that have been going up in here. And my 16-step drum sequencer project is published now, so you can go check that out if you want to build your own, find out how that was made. This will tell you how. I also have a show on Tuesdays, which is the product pick show. And on that, I like to pick something new in the store or something interesting that isn't necessarily new. Give you a big discount on it. This week was a 50% off discount. And it was this one right here, ESP32C3 Cutie Pie. Here's a little 1-minute version of that. Check it out. The Cutie Pie ESP32C3. This one has both Wi-Fi and BLE capabilities. Not only can you code this in Arduino and in MicroPython, but you can also use Whippersnapper. It is connected to my network over Wi-Fi. I've connected up one of our little step switches here, this LED to turn on. When I press the button on the Cutie Pie, it's going to send a command over Adafruit I/O saying that I've done something. Now you'll see an update in my dashboard, and you'll also see I just got a text message, and that happened really quick, like within a couple seconds actually. It is the Cutie Pie ESP32C3. By the way, I'm getting a little error message from YouTube saying it's not receiving enough video data to maintain smooth streaming. Let me know if it gets really choppy to the point where it's unwatchable, and I will try to kick the server there a little bit, kick the stream. What else is going on? Hey, next up, why don't we I'll pause a moment and see if the stream is good enough to continue without a little restart. And then if it is, I'll do a CircuitPython parsec. In very minor gear news, I got 2 remote controls for old TVs in the mail today. The hidden cost of finding free TVs on the side of the road is you almost always have to go and spend between usually, I don't know, $5 and $10, sometimes $15 on eBay to find a proper remote control. But I'm excited because one of these for this giant 32-inch Panasonic has picture-in-picture. And you can't access that without the remote, but that means I can do picture-in-picture, which is exciting. Whatever happened to picture-in-picture? I seldom see that on modern flat panels. Why? What happened to it? Hey, thanks, Foamy Guy. Foamy Guy said that it looks like the stream may be improving a little bit. I don't know what's your deal there. Actually, I think I'll blame the rain and the internet. So let's do it. Let's do a CircuitPython parsec.
CircuitPython parsec.
All right. Let me pull that out of there. Hey, there we go. For the CircuitPython parsec today, I wanted to show you how to double-click a button. So this is related to the same debouncer button library that we looked at last week. And inside of the debouncer library's button functionality, not only can you look for short and long presses, but you can also look for multiple short presses. So what I'll do right here is when I press this button, it will beep. And that's if I do a single click. So I got a beep. I have a little pattern that's going to play. If I do, however, a double click, you'll see that it's changing the colors of the NeoPixels. So single, whoops, there we go, single, double, double, single, single. So how you do this in code, let me grab my code window there. Main thing that's happening here that's important is I'm importing the Adafruit debouncer button from within the let me say that again. From the Adafruit debouncer library, I'm importing button. Then I set up the button pretty much as normal. It's using digital I/O. It's a pull-down resistor input for the pin. And then when I set this up, I say button on this button pin. I have long duration in there. I'm actually not using it this time, but it doesn't hurt. And value when pressed is true, which is just the direction that the button is going to pull or up or down when it's pressed. And then the key thing here is, in my main loop, I check for button updates, as you normally do with debouncer or button. If it's a button.short count of 1, that means I've just pressed it a single time. And when I do that, I'm playing a tone, and then I'm setting the current tone, and then I'm playing that tone. When it has a button.short count that's greater than 1, then it's going to consider it essentially a multi-click or a double-click. And you can see here, when I do that, in my output it says, okay, that was a multi-click of 2. I'm actually counting, there we go, I did 3, 6. So depending on how granular you want to get with your interface, which can be pretty tricky, you can set up single clicks, double clicks, and even triple clicks. Sometimes those are a little hard to pull off. And you can set different outcomes depending on the number of that shortcut, that short count value. And so that is how you can use multi-clicks inside of CircuitPython. And that is your CircuitPython parsec.
CircuitPython parsec.
All right, I do think I see some buffering going on, so getting better on YouTube than Twitch. Okay. All right, let me see if I can kick this thing real quick. All right, we might be back up and running again. Let me know if anyone's having good performance on any of the streaming services there. And I'd be curious, was the CircuitPython parsec part watchable or not? Because I'd love to edit that section and repost it later. So let me know. If it was, I don't always, sometimes I'll set this up to record to disk, so the whole live stream is recorded to disk also, which means I'll have a clean copy. I don't always do that, however, and then I sometimes regret that. I probably should always do that. If that was bad, I'll even redo it. Oh, parsec was okay, says C. Grover. Okay, great, thank you so much. Yeah, that's a pretty cool feature. So the fact that inside of Debouncer button you can do the short click, the long click, and the multi-click. You can't do multi-long clicks, and I believe a long press will count as part of your short click count if you do one last one at the end, because I think it counts the press, not the release. But you can find all that out, by the way, heading over to, here's a little bonus thing. Let me jump into a Chrome window here, browser window. I'll show you sometimes, it might not always be clear how to find out some of these little details about a library. So what I'll often do is head on over to GitHub, and I think I can go to github.com/Adafruit. And then from within here, there's a find a repository. Once you're, don't use, I know sometimes there's a search up at the top that's kind of useless, but once you're in a individual or organization's GitHub, you can use this little find a repository fairly well. So I'll do, I know this is part of Debouncer. So this will show up Adafruit CircuitPython Debouncer. So I'll click on there. Code is here. Examples are usually here. And in the README, there will usually be a link to the Read the Docs API documentation. So if the answer I'm looking for isn't just inside of the, hold on one second, let me move this thing over here. If the info I'm looking for isn't in the examples, it's often where I'll look. Sometimes I'll look at the library code itself, but a really good idea is to head over to the Read the Docs. So once you click that, now you'll see on the left, here's the API reference for Debouncer and its two sections. What are these called? Functions? The sub functions of them? Help, someone tell me. Foamy guy, you must know. So Debouncer has a thingy called button and a thingy called Debouncer. So if I click on the button thingy section, this will give you all of the API documentation. And in here we have info about the parameters it'll accept. So the pin, short duration, milliseconds, if you want to define the length. Thank you, classes. These are the classes. So button class of the Debouncer library has pin, short duration, long duration, and value when pressed as the inputs to it. And then you can use long press to find out if you've done a long press, if it's pressed, if it's released, and then this integer of short count. It returns the number of short presses. So you can ask for this, and that's what I'm doing when I'm running that little check in my code to say, hey, tell me the short count number. If it's 0, then I'll just consider it a single click. If it's greater than 1, I'll consider it to be a multi-click, and then you could make that more granular depending on what you need. Or doodads. Yeah, Andy Calloway and Foamy Guy, I think you're both right. Classes or doodads. So the Debouncer doodad called button, very helpful. You can, of course, do all this sort of stuff with like the keypad library, which is really great for a lot of things. It doesn't have this functionality built in, but you can, as I mentioned last week, you can roll your own functionality in other libraries. This button's just convenient because it has it built right in. All right, and that is that. And thanks for the help, Andy and Foamy Guy. Appreciate it. Hey, over in the YouTube chat, Daniel Mitchell says, hello, greetings from Switzerland. Hello, thanks for joining us from Switzerland. Appreciate it. DJ Devon 3, welcome. Just got in. I'm going to watch the whole thing again tonight. All right. So, what's next? I wanted to follow up on the Pico NES Nintendo Entertainment System emulator thing I built last week. That is this. And I've got a couple of updates on this. One is I got a lot of wires here. So I've got a controller, an HDMI, and a power. But I just wanted to let me put this actually in the down shooter. I ordered a little dongle, really neat little dongle version of the on-the-go cable. Whoops. Grab that controller, it just fell. Don't dangle these from a USB cable. It doesn't work real well. So let's see, do I have the old one here? So this is I think it might be called a power injection on the go cable. So it means that it allows you to inject power over that. So that power is going into your microcontroller, in this case the Pico. And it allows you to use a sort of client device. So it can use the Pico as a host and plug in a peripheral, USB peripheral, in this case the controller. So these are pretty cool, and in some cases they may be exactly what you want, but I wanted it to be a little smaller, and so I got this doohickey here, which is pretty neat. And you can get these, I got 2 of them for like $8 on Amazon. So this is the same exact thing, just in very compact form factor. So it passes power through top there to the microcontroller, and I believe it's also routing that power to the USB plug for the controller, in this case, the PlayStation controller I plugged in. So kind of neat. These are the 2 main kinds I've seen. There may be others, but these are pretty cool. So that was one update. Neat little dongle. These come in left-hand and right-hand direction ones, so depending on the rest of your setup, you may need it to go one way or another. But I like having both now, so these are convenient for certain things, but that's pretty nice and compact. And then I got, move all this stuff back here. I got inspired after putting that together last week to design a little PCB for this thing. So as you may know, there is a Pimeroni PCB that does pretty much exactly what you need. I didn't have one, and it has more on it than I needed, and I kind of wanted to build my own so that I could then make some changes to it. So this is the setup that I have. So it's really Pico, pins going to the DVI breakout for the video, HDMI video. I added something here that I haven't tested yet, but it's just a switch for the enable pin or the run pin, which should allow me to turn this thing on and off just from a switch there. And then the micro SD card there, which allows you to have your games, your ROMs that you're going to be running. So here's the schematic for this. This is fritzing, by the way. That's what I use for the documentation of projects on Learn Guides. Here is the schematic of it, and then this is the PCB that I designed. So I'm using, when you get, I have a guide that I put out, I think it was maybe more than a year ago, which was the Pico little macro keyboard for, I had it set up doing MIDI stuff, but it was, it goes into the details of building a PCB in fritzing, including some of these parts, the Pico part in particular. There are 2 variations of this Pico part in fritzing, at least when I looked, which is a while ago now, so there might be more. But there was a through-hole version, and an SMD version. So I'm using the SMD version here, which means that it's going to be a little slimmer, a little faster to solder this. You don't have to solder header pins and then put it in. It means it's not detachable, but a Pico's $4, so I don't care. And you just solder those castellated pads right to the pads that'll be on the board. The benefit also is a little bit easier routing. You can run stuff underneath without running into holes, which is where those through holes would be. And I've just put the SD card off to the side here. I have the HDMI DVI output up here. It's my Pico, so the USB will be off to the side. Hopefully, I actually did this before I bought that little on-the-go dongle thing. Hopefully, it'll still fit here without blocking the micro SD card. If it does block it, I'll switch to the other one because I have the right angled instead of left angled one. And then I put my little switch here. So that I can show. Let's see. I thought I could show the bottom layer. Did I just make it all go away? Huh. Didn't like that at all. Oh, it just kind of went off to the side. Maybe I misclicked. So this is the top view of just the top layer. Here's the bottom view of the bottom layer, so you can see what's going on there. So it's mostly just a big copper ground plane, so all the grounds go to it. I did mention in the guide that I did for the Pico macro keyboard, 21-key keyboard, that there is seemingly a bug in Fritzing, or at least the version I'm using, where it will never resolve the rat's nest lines for ground when you are using a ground plane, copper fill ground plane. So you can ignore those. They look like, oh no, you've forgotten to route something. That's not the case. Those are routed. And then I put some mounting holes here for the PCB to go into some kind of an enclosure. And then there are also some holes that just come in the footprints for our micro SD card and HDMI DVI output. I put the URL on the bottom there of the project that I'm using, so I remember, and anyone else who wants to use this, I'll post it if it works. Haven't tested it yet, but the exciting thing is that I think I made this on last Friday, and I have 5 PCBs arriving sometime today for the cost of $2 plus maybe $18 shipping. So I think for 20 bucks I'll have 5 PCBs of this, which is pretty great. So I was hoping it would come in time for today's show, but it didn't. So I'll have a chance to put one together, test it all out, see what's up with it. The other update is that since this project, as it currently is, uses USB game controllers, and the USB gamepad stuff is pretty finicky and specific. So this was designed to accept 3 particular controllers. One is a really hard to find iBuffalo brand USB NES/Famicom style controller. You might find one on eBay for maybe 50 bucks or more. They're really hard to find. The other 2 are a PlayStation 4, the DualSense 4, which if you happen to have, awesome, I do. I have 4 of these things, so that's perfect. So it's essentially free to me. Or the PlayStation 5, what do they call it, the Dual Touch controller, which is probably not going to work with a clone. So these are literally that one specific, got to be from Sony, and that's, I don't know, like a $70 controller, right? So what I'm hoping is to see what it would take to use a separate, potentially either a separate microcontroller that can be spoofed to speak the proper USB to look like, say, a DualSense or DualShock 4, but have a shift register input for a real NES controller. So I'd love to mount an NES controller plug on here and either another microcontroller or get the Pico, if there's enough pins and memory, get the Pico itself to just read the shift register of the controller. So it'd be really nice to have this be plug and play with a real controller. Oh no, we're getting buffering again. I hate buffering. What's going on? Let me see if there's... Bitrate is lower than recommended, it says. Doesn't look terribly lower, so maybe that's better now than it was a second ago. I'll let this hang out for a second. So those are my plans. There's a lot of owls over here today. What's going on with all the owls? Many owls. Looks okay here. Yeah, so that's the board. Should be in sometime today, according to DHL. and I will probably show this next week if I get it up and running. My other thought is that this may work well with some of the HDMI graphics code that Jepler and Paint Your Dragon, Phil Burgess, have been working on. They've been testing their stuff using the Pimeroni board, and I may just pick one of those up too, but I don't have it. So if this works for that, then yay. I know there's more on that board than I have here, and I just don't know what of it is necessary, so we'll see. All right, so that's my update on that. And I'll wait a moment to see how our buffering situation is going before I move on to my next project here. So give me a shout in a second here. I'll bring up the Discord in the meantime. So let's see, what are the thoughts? Where do the owls come from? Over the ground, OTG. Ah. Yeah, I don't know what's up with Lars back there, honestly. All right, how is it now? No buffering on the Twitter post. Oh, hi, DZ. Thanks for watching on Twitter. We do broadcast there. I didn't know if people were watching over there. Okay, good. Well, at least seems like we're working in some places. So what I wanted to do then is talk about this this next project. So I had a project idea about making a sort of a soundboard using capacitive touch, and I was inspired a little bit about the idea of like a speak and spell or a see and say, if you remember those. They look like this, and Fisher-Price has this version of it out that looks a lot like the old one. It's a graphic design is throwback to sort of the 60s illustration style of the original. It uses a pull cord, and when you release that, it spins the little spinner there. And what you do is you put that on an animal you want to hear the sound of. So let's put it on duck. And then when we pull this, so it said there's a duck. And then wherever it lands, that's what the next sound is going to be. So you can either just let it play roulette for you, or you can place it on a specific animal and pull it. So Lamore said that they have one of these, and theirs is kind of super loud. There's no volume control on it. Hard to hear, though, because they said the audio sounds kind of clipped. And why don't I try to take one of these apart and see if we can replace some of its innards and take over how it works, which will be, I think, a lot of fun. So what I did is I actually got two of these. Let me jump over to the workbench there, and I'll show you. So this other one that I got is, I think it's going to end up being the same fundamental guts. Most of the mechanism and the electronics, I think, are going to end up being the same. So I started with this one. So this one I've taken apart. Try not to lose any parts. It looks like this. It allows you, again, to select your animal, and then there's a lever instead of the pull cord that does, I think, the same thing. When this reaches the bottom of its turn, it presses a button, and that button that it presses is based on the location of this. So I'll show you how that works. This one has an added feature of there's a little micro switch that allows it to have an additional 10 sounds. When this gets turned and clicked into place, you get another 10 sounds. I don't think I'll need that feature for the vintage style one, though. So here's mainly what I removed, which is this. Oh, you know what? Let me see if I can bump up my exposure here. Hold on. Is that going to work? Nope. So when this gets pulled, this spring which I detached is connected to this piece of gearing mechanism, and when that reaches the base is when it triggers the sound, and then the spring pulls this back up, and that little governor and mechanism causes this to spin. It's got a little weighted flywheel kind of thing on there. But the part we care the most about is how does it actually trigger a sound. So I've taken this apart enough to start tapping into the button mechanism, so I won't be able to run it fully right now. But essentially, this is the electronics that do everything. It's got 2 AA batteries for power. It has a little speaker down here, the microcontroller on here, power management stuff. These are little copper traces that are the switches, which get pressed just like pretty much like any video game controller or rubber dome keyboard, which is one of these rubber domes with the carbon pill down at the bottom. Let me zoom in a bit closer and focus on this piece here. So these things press one of these 10 buttons. So normally, this is in here, and then the PCB is on top of it. So what happens is when this lever gets depressed, you'll see one of these, if I'm applying pressure, which is how it would normally be, that board is holding in place, you'll see just that, let me put it at an angle, just that one pill there is getting pressed. And it's actually that right there. Now, the choice of which one is getting pressed is based on this piece of plastic, which is tied to the position of the arrow. So if we point the arrow at the duck or whatever, that's the button that gets pressed, and then this thing spins and goes about its way, so it gets out of the way. So it just presses the button once, and then it goes and spins. So that means pressing these will cause the circuit to make a sound. So what I did was I first tested that out. So I just pulled it apart, and I just shorted those actually with a piece of metal. That works, as do these little carbon pills here on the silicone button pad. This really conveniently, let's see, is that the closest I can get? Yeah, really conveniently has test points right next to each of the little copper, what are these called? I'm going to call them doodads too. These copper traces that are bridged by the rubber domes. So I call those the switches, basically. So these copper switches each have a test point next to them. And then there's an inner common here. So half of those teeth are on the common side that run to VCC. And so this VCC then normally goes into the rest of the circuit, lets the microcontroller in there under that epoxy blob know which one has been pressed. So what I did was I couldn't use those while VCC was connected into this circuit, which it's connected in 2 places into the circuit. So I cut a trace, and I'll write this up in a guide, but essentially you'll see that inner row there has a little cut mark that I put in right here, because that's where it, at this sort of T-junction, that whole inner row of VCC runs left up this side of the board and right up this side of the board. Initially I tried just cutting it here, didn't realize, oh yeah, it's going 2 places. So, so now it's out of that circuit. Means that we have essentially infinite resistance when there's no continuity, when no buttons are being pressed. And when they get pressed, it's the copper pill is maybe like 60 ohms of resistance or something like that. So that's easy to detect with a microcontroller. So what I've done is you can see I soldered some thin bodge wire to some of these test points. So I have test point 5 here, which is this first button. And I have that running into pin 3 on this Metro. I have another one. Actually, my code doesn't check it yet, so I'll actually detach that for clarity. Then the other one is the VCC. So the VCC line there is essentially my common. I have that running to 3 volts on my Metro. And then I can use, I think I'm using the bouncer to check and see if one of those gets pressed. So let me grab a proper USB cable and plug this in over here and show you it working, and then we can take a look at the code and some ideas of further plans with it. And I am going to go ahead and check Discord on my phone just so I can see if we have any streaming issues, since I was having some before. Let's see. Okay, good. All right, so let me know if there's any issues. So let's see. I think something's up because this should be showing me. There we go. I just had to reset it. So I have this displaying a red on the onboard NeoPixel. I just have it displaying red under normal conditions when nothing has been pressed. And then if I take just one of these little carbon pills here, and I'll sort of refit this into place a little bit. I won't put it down perfectly. So now you should see when I press this first button, the microcontroller can register that. So essentially at this point, the guts of the CNC are severed from this nice little button pad. And so I should be able to just read all 10 of those, and I'll use a microcontroller that has enough GPIO that I can keep that simple. Should work with maybe a Cutie Pie, more likely since I want to do other stuff, although it might be over I2C, might not. I'll probably put a Feather in here or a KB2040 or something like that. So what I want to do is I want to be able to read these button presses, which is all that this will do. Again, there's no motor in here, so spinning, that's nothing I have to worry about. That's all just the spring-loaded mechanism with the flywheel to govern the speed. And when I move that arrow, it'll tell which button to press. I'll be able to read that on a microcontroller. And then I will try to just reuse this speaker that came with it, which has a nice sort of soundboard arrangement. It presses into this slot here, and then it has under tension of this plastic. This is screwed into here, and it's pressing it down really nice and hard, which means it uses the whole cavity as a soundboard to vibrate and essentially amplify the sound. It sounds really tinny when you take it out. It sounds nice when it's in, nicer. So I'll probably just desolder that speaker from here and run that through a little I2S amplifier. So my microcontroller will need to do I2S. So maybe a Feather, maybe not. Feather might be overkill. Lamar asked me to check and see if I can get away with maybe using a boost converter and powering it off of these 2 AA's, which would be great. That means you could put this together and it would look like nothing has changed about it, but I'll be able to play my own wave files. So I'll use CircuitPython and Audio I/O to play back wave files, and might mix it up a little bit. Might not be the same cow and duck and pig that we're used to. So wait and see. But this right here, I kind of think this was the hardest part, was just figuring out, all right, wake up Metro, figuring out how to tap into this with minimal invasion. So I didn't need to add tact switches or read the position of it with some other kind of sensor, like a Hall effect sensor. Nothing fancy necessary. I'm so thankful this is actually a really easy to use, reuse actually, this little guy here. Also, absolutely useless coincidence, but kind of fun anyway. The spacing of these 10 buttons happens to be a really nearly perfect match for Circuit Playground Express for the LEDs. So if you look at where the NeoPixels are on a Circuit Playground Express, and you look at where these little pills are, they happen to line up. There's nothing I can do with that, but I thought that was just kind of funny. I looked at it and I was like, wow, that's a really familiar pattern of 10, where it was probably closer to a perfect 12 with 12 o'clock and 6 o'clock pulled out, which is pretty much what our pattern is there. So I'll see. That might make a cute diffuser of some kind. If you remove the black carbon pills of that, you get a kind of nice little silicon diffuser. Could be fun. So that's that. So that's what I'll be doing with it. This is the one I'm going to do it to, though. Once I get it proved out with the other one, Cow will be saying new things by the time we're done. Might be fun to sample the farmer there who does all the talking, or whoever that is, and have him introduce other sounds. Yeah, you may have also, by the way, I think there may have been versions of this in maybe the 90s that were circuit bendable. I feel like I've heard circuit bent versions of Speak and Spells at least. Not sure about these. There's also a Soundgarden song that has like a massively slowed down, terrifying version of that on one of their early albums. But this one, yeah, nothing to... And actually, I'll say, I haven't looked at the history of the CNC, but I wonder if the earliest ones were like some other pull toys that had essentially a kind of a sound disc, like a record that they were playing. I think some early pull string toys were actually playing a form of a tiny phonograph-like thing. I'm not sure if the CNC did or not. All right. So let's see, what else is going on, Discord and YouTube? The stream was stalling, but now it was back. Thank you. Thanks, Dave Odessa, for answering that when I was asking. Let's see. Touch button might be a name of it, regardless of it being capacitive or not. They might be called touch buttons. Or touch sensor. There's ducks. All right. DJ Devin, I'd love to be able to use HDMI with CircuitPython. Not sure if that's an unrealistic expectation or if custom UF2s are able to do that kind of on the Doomdo. Oh, actually, yeah, that is actually working. It's in works. It's not released yet, although if you scroll back in the feed here, look for, just search for Jepler, his messages last night, or look at the show and tell. He has code that will allow you to run Adafruit graphics, I think on one Pico using CircuitPython, talking to another one to feed it display I/O stuff, and then the second Pico is sending DVI. So I think we're inching towards, maybe it's faster than inching, towards being able to run DVI or HDMI out of a CircuitPython device, which is fantastic, really cool. All right. If there's nothing else, I'll thank you all so much for stopping by. I will remind you that this may be today's coupon code. I'm nearly certain that it's not just lemon. I think it was lemons. And that'll get you 10% off in the store. So head on over to adafruit.com, throw some stuff in your cart, and on the way out, look for the coupon code field, type in lemons. If it yells at you and that doesn't work, make it lemon. I'm pretty sure it's lemons. And I am now reminded to go pick some of our Meyer lemons off the tree when I finish up here today. Thanks, everyone. I will see you on Tuesday with another product pick of the week. So tune in tomorrow. There should be a deep dive with Foamy Guy and possibly other stuff. Stay tuned on our blogs or type in !showtimes in Discord to see what's planned, generally speaking. Thanks, everyone. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.